I'm Sophia.
I'm Sia.
And I'm Melina.
And our presentation was on photolithography.
So photolithography is a method through which someone uses light to basically create a certain pattern. So basically, photolithography is a top-down process. So it's basically going from a macro scale to a smaller scale. And so this process begins with a substrate, which is a polymer, and it's like the basis of this what we call a photoboard. And so then it's coated in a substance that is essentially like an active ingredient. It's called so it's any ingredient that you want to be part of the final product. So essentially, if you were creating a system of wires, you would want to use a conductive material such as copper. Next, this is covered in photoresist, which is basically a light reactive polymer. And on top of this, you place a mask, which is basically just the pattern that you want to have on the final product. Then this is exposed to UV rays. What happens is that whatever material was underneath the mask, it remains solid, basically. It's not exposed to UV light, which means its chemical substructure does not change. But whatever material was not underneath the mask, it's exposed to the UV light, and thus its chemical structure is changed, and it becomes soluble. So once this photoboard is removed from underneath the UV light, it's placed into a developer solution, which basically removes the photoresist that was on all of the exposed material. Then it's placed into an etching solution and stirred until all the excess material that is now soluble is removed. Once that is done and you have like a distinct pattern on your photoboard, there's a device called a stripper that basically removes all the remaining photoresist on the pattern. So, yeah.
So photolithography can be used to create integrated circuits or an integrated chip used in several of our technology that we use today, like computer chips or in your iPhone. Currently, in the iPhone 7, there is 3.3 billion transistors, and transistors are composed, or each transistor is about 10 nanometers in size. Let's explain this picture. So the first, in this diagram, in this diagram, we can see in the first quadrant, we have a person with a white piece of cloth, and we thought this represented the substrate, and they're dipping it into what looks like a cloth dye, and we thought this was depositing the photoresist, which we can see in the next picture. Then we thought the third picture was represented the mask. After you have the mask on the photoresist, cutting it out represents how we developed this pattern. Yeah, sorry. And then in the last, or not the last, the fifth picture, we see what we thought the person cuts it into a shirt, and we thought this was the etching portion of this process. And then next we have the person says it's maybe it's a little too dark, so they dump it in some water to rinse some of the dye away, and we thought this was the stripping process, or removing the photoresist. Sorry, not removing the photoresist, removing the photoresist, sorry. And then lastly, we see here, there's the final product, and it says here it's shorter and tighter. It's best running apparel with it gets cut off, but we think it says resistance. And yeah, so.
Okay. So we thought overall that this picture was really good and clear when showing this process, but there were a few concepts that they left out. One of the concepts is the idea of like using a clean room. So when working with nanoparticles and doing this experiment, we didn't use nanoparticles, but when you do this really small, you need to make sure that nothing disrupts or like gets into the design and messes it up. So you use clean rooms. And we actually visited a clean room, and in the clean room there were only like 100 nanoparticles per square foot. So a way to incorporate this into the picture would be to like show what not to do, and maybe have like some coffee that you spill onto the design, which would mess it up, and we don't want to do that. Another concept that we didn't think was really expressed was exposing it to UV rays after applying the mask and the photoresist. And we said that maybe you could like dry the cloth and give it some time to soak in the dye. And we also said that it might be better if the illustrator were to differentiate between etching and developing, because there were two different things. Okay, forget it. Yeah.
You mentioned UV light at the very end. How does the wavelength of the light that you use impact your ability to scale the mass?
His question was, how does the UV light can you repeat that? Sorry.
The wavelength of the light you're using,
Oh, okay. So,
So basically, the wavelength it's basically scaled to how small you can create this pattern. So if you were to use something of like larger wavelength, like visible light, or like on the other end of the spectrum, then it
wouldn't work as well.
Yeah, the image wouldn't be as small. So to create something that's nanoscale, you need UV, just because of that wavelength. You require that wavelength, or that range of wavelengths. But if you wanted to create a pattern that's even smaller, then you would have to use like X-ray and even gamma rays, which people don't use, is dangerous,
Yeah.
but
Able.
you would have to use much smaller wavelengths.
Yeah.
So you talked about the clean room environment, right? So why does that matter? How big the particles are, how many or how few there are?
Okay, so the question was, why does the cleanliness of the clean room matter? I guess. So it's really important when you make like or you make this with like nanoparticles, that you don't add in other nanoparticles that aren't supposed to be there in the air. Because if you were to do this, it would just like completely mess up what you were trying to make.
yeah, it could ruin the pattern that you put on your chip. Like little hairs, or I don't know, dust, which could affect the whole thing.
Same topic. If that's a clean room, what, 100 nanoparticles per square foot? What's an unclean?
This right here.
Basically, because there's
So what are we talking about per square foot?
Oh.
Freak me out.
we actually asked that
Yeah,
question.
we
Asked one of our counselors.
yeah, we asked one
But
of our
that-
counselors, but
His response was, that would take a lot of hard math, and right now I'm too tired. So
Yeah, basically, yeah.
oh, he said about 1 million cubic feet. Is
Hundred.
a million nanoparticles per cubic foot. Is that how dirty? A dirty.
To be more technical, it's like these particles that are bigger than approximately a micron. Something like a pollen, or a little smaller pollen, very small pollen.
One of the key concepts of lithography is the idea of a mask. So how can you put that idea into this cartoon?
Said
yeah, we said that we said like drawing it up. Yeah. Okay, so we said that the mask was the person like drawing out the pattern that he was gonna cut. So
but we thought Yeah.
Mm-hmm.
Mm-hmm.
modify it to make more of a real, to capture the essence of what is a mask.
It could possibly be like a stencil, or maybe like we were talking about incorporating the exposing to UV light as a part of this cartoon because it's kind of not clear or not even there. So maybe you could incorporate how like you want to have some kind of design on there and then use some kind of stencil to like incorporate that.
Just within sewing, what could the mask be? You ever actually sewed?
Oh. Like, could it be? No.
Either.
Fabric? I don't know.
Fabric and
Thread? I don't know.
Oh, you
Is it?
buy like pieces of paper to like put.
Oh, okay, yeah. To to check the size. Is it for the sizes or is,
Yeah. You, oh.
is that what? Yeah, we don't
Right.
sew, but okay. Yeah, that could be enough.
Hopefully a short one. The illustrator also spent a good amount of time writing shorter and
And tighter.
as a description of benefits for this. Can you relate this illustration to what in reality this might mean and why the illustrator put some effort into talking about the benefit of shorter and tighter for this?
So the shorter and tighter would relate to the like a smaller resolution because it's nanoscale. So that's basically the that's what that means in terms of photolithography.
Directly to the application of the technology, like let's say this is the technology you're talking about, when the illustrator might be suggesting that the result of such technology is shorter and tighter. Can you perhaps link that to the real world of why people would use a technology like photolithography?
So I think part of it would also be like making things smaller. Like one of our instructors gave us a lecture on basically like I see the microchips and how they've been getting smaller over the years, and that's in large part due to the nanotechnology. And so I guess that would be like not only have they gone smaller, but they can also incorporate they can hold much more information. So yeah.